All right. So after we left off with player movement and player health, I did post up a bunch of stuff here. I got a feeling I'm going to move this into section 2, but let's look at this right here, which I did talk about before, but now we get to go in a little depth here. So this is the Unity manual. It's super useful. Up here at the top, you have manual and scripting API. In scripting API, when you start coding a lot more and you just want to like look stuff up, like wait, in a game object, how do I look at like what its parent is, or how do I get its children? You just go to scripting API and you look up game object. So the manual and the scripting API are going to be great resources. And then just asking these questions. So there's like the Unity forum, and there's Stack Overflow amongst other forums. But the great thing is if you just know how to pose your question pretty detailed, like pretty accurately with your words, you'll get a lot of discussion forums where people have already kind of discussed and found alternate many solutions to your problem. So you're going to want to get used to using these resources. So Unity manual. So I talked about the Sprite editor before. If I go into character and sprites, this is Mr. Alien. He's like this little Easter egg down here. I'll close the chat panel for right now. Here is our project view. These have our assets. When you click on an asset, in this case a PNG, an image file, files that sit outside your project that are loaded into memory, that get connected up into your hierarchy, usually as a component object. When you click on an asset, you'll get details about it in the inspector. And the main thing is, what is this texture being used for? Is it used for 2D or is it being used for 3D? So 3D is default. These are the major things you'll use them for. As you can see, there's other stuff I'm really concerned with. Hey, is this image being slapped onto like a little rectangle in a 2D game format, or is it going to be pumped through a little bit more sophisticated of a shader and somehow be applied onto a 3D model? And when we're dealing with sprites, we have single and multiple. There's this other one, but usually the standard is like, is it just one image? Is there just one sprite in this image file, or is there multiple? So this is an example of a single. And let's look at player death, because I didn't open that last time. And if you open it, here's all the different. So if you click on the image, you could see there's like 5, 10, 15, 16 images that get played in sequence and make them look like the player's dying. And then if you click down here, and you could just move between them. In fact, this is just what the animator is doing, basically, a fixed time step. Cool. And so these are the sprites underneath them, and you can see their names. And then this is multiple sprite view, and then here's a sprite editor. That's what the first stuff I want you to look at. And there's different ways to slice up the sprites from it. And so you have these slicing tools, or you can do it yourself, but you're just like chopping up an image into multiple images and then giving them distinct names or what have you, so that you can access them later on in the sprite render in the animator. And anyway, here's documentation on it. So just spend your time with it. I just, went a high level in just to get you accustomed, just to give you the big strokes of the general workflows. And then as you want to dive in a little bit more, you can learn about them. And there's a whole bunch more stuff about sprites here. You can dive around here. And then sprite renders later. And then the next resource I gave you was this tutorial. And these are really well laid out, so just take your time with them. And this goes through the package manager and how to bring the sprite editor in to begin with. Which for us, since we created a 2D game, the package was imported for us. But this goes through like those import settings that I was going over, and all the different settings you can do. And in this case, looks like we have multiple sprites that we're going to chop up, and how to cut them up and rename them. In this one, we kind of looks like they're using like an automatic slicing grid by cell. Automatic detection. Yeah, it's not grid and cell. So I was like, there's no way this is laid out like a grid. It's just like detecting the empty space around like the high alpha, the transparent areas. So it's detecting that here's a bounding box around something that's visible. This should be one its own sprite. And you can tweak them as you need to. So adding this custom outline, what is this for? Usually that, to me, that's like a soft deformation. That's if you're like animating it. But anyway, it's interesting. Oh, it's like if you want it to be more precise than just a big. Usually I just do like the squares right around it. But cool. So I just wanted you to spend some extra time with this. Is the project side. This is the asset side. So this is bringing files in and prepping them to be used in the game engine. So that's the sprite editor side. I'll just pause for a second. Was there anything of interest or any gotchas, or was anybody exploring this and they got stuck with something, or was anything of particular interest to note besides kind of the general workflows that I've discussed? Cool. So next up was render documentation, render tutorial. This one, this is the actual component. So this on the player, sprite render. This is when you bring your assets in, you plug them in as a sprite property here on the sprite render. Remember, behind the scenes, this is a object that's coming from a C# class. And so these are properties that are being exposed, and this is like the actual sprite, like the texture that you want, and then this is a color overlay. That's why the character looks blue, but in the file he is white, because you can do like this overlay on top, and then you can flip them in the X, which is super useful for moving, which we do a lot. I didn't see the Y, but I guess if there's like reverse gravity and he comes flying up and he hits the roof and he's like running on the roof, then you would want to flip on the Y. And then behind the scenes is all being plugged to a material, which is a wrapper for a shader, which we're not getting into yet. But just note that all this render stuff all gets boiled down to shaders, which we're going to have to spend some time with. So here's the sprite render, and if you're interested, I should probably put this link up too. So here's a sprite render on the scripting API side, and you should get used to looking at the scripting API as well. But let me just pop back to the manual for right now. So this is the component object that you're used to seeing. And here are the properties being exposed, and I talked about the sprite, the color, and the flip. Right? And there's some other interesting stuff. I think sorting layers might be just worth a quick note, since 2D graphics often come into conflict because they're like sitting on top of each other. You don't know like what's the order of rendering. I think in this game level, there is a little bit of depth to stuff. There's like different Z values, different distances from the camera, like for the far back, near back, far close stuff. So it's like the camera knows how to render the close stuff in front of the far stuff. But if you do layer stuff on top of each other, like knows, like same X, Y, and Z, like there's no difference in the Z, that's when the sorting layers come in. And that's like, wait a minute, the camera's like, oh wait, I'm supposed to render this, then this, and then this to the computer screen. And in UIs, this gets really important. Like the order that you lay out the user interface elements in the game objects really impacts how they get rendered to the camera. And so, yeah, that's a color overlay in the materials that we're not really going to get into materials for this section. Cool. And that's the sprite render. And that let me jump back into the scripting API. So since this is a component object, this is a C# class, and you can call onto it like, you're gonna like drag stuff onto here and connect it up in a nice GUI visual way. But sometimes you don't want to do that. Sometimes you want to do that by code, and if you want to like do this to 10, 100, 1,000 objects, especially at runtime, you're gonna have to do it by code, and usually, so it's good to make a connection that all that stuff is actually just code. All those nice little properties sitting in the GUI, and you can just call them with your own stuff. So here's this. Usually there's like a big example or description at the top showing you like some code. But down here we can see that it lists out the properties. So this is the sprite render component. And you can go right in and change the color, the flip X and Y. Like you've seen us do this, like the flip X with the code. And I'll go show you that in a little bit. And you really just have to look at them. Like if I click on flip X, it says it's a bool. So if you want to set this to true or false. And then there's methods. Don't really callbacks for reg or string. Don't really use that. Getting a little too advanced. And then inheriting. So some of this stuff might be useful too. Like you can go up to the game object. Since it's a component object, you can go up and say, hey, which game object are you connected to? And you might need that at runtime. And so that's inherited since it's a component object. It's inheritance from a base class. And there's other things that can get to the transform component because it's a required component. And some other stuff that might be of interest to you. Get components that are also sitting on the game object. And then static, I think it's worth just mentioning that static means it's not connected to an object, it's connected to the class. So you don't have to go like object dot, you could actually just call the class and say destroy on this. So it's sometimes you'll see like destroy and there's like no object, it's just like a command, like capital D destroy, but really it's like connected to like this super object, like this game object or what have you. So let's see. So that was sprite render and scripting API and sprite render in the manual. And here's the tutorial I asked you to do. And so it's just a more interactive way than just kind of reading through the documentation. But you're going to be creating your component, your sprite render. You're going to be reading through the properties and which ones you want to set. Different types of draw modes, connecting up the material, and we're just using this like Sprite's default material. It's all set up for you, dealing with 2D graphics, and flipping the sprite. This guy's like some Viking hero. Interesting, you see like the sprite editor with every part of his body is like separated. Because you want to distinguish them as separate sprites, and they get moved together in the game engine in your game so that he looks like a real guy, and you might animate all these different body parts. Looks like he's breathing and running and attacking and stuff. Yep, sorting layers. So it's good to understand like the beard, like for example here the chest is being rendered on top of the beard, which is part of the head. So really in the sorting layers you want to make sure that the head sprite gets rendered after the chest sprite. That whichever component has the sprite render for the chest, that should be rendered first, and then the head on top, and then it looks correct. So those are sorting layers. Cool. This is stuff I've talked about before. I just wanted you to spend some extra time with it and explore it a little bit more in depth and see if anything. I'll just pause for a moment, see if there's anything anyone wants to bring up, anything of interest. I wanted to explore a little deeper or something to take note that you thought was interesting with the class. Cool. I just saw a few extra people came in. And I'm recording the lecture right now, but I'm just going over the sprite editor which is when you have your assets, your image files, your PNG files, or what have you, and you need to set them up, you need to chop them up for sprites for use in your game engine. You have access to the Sprite editor, which I've covered before. I just want to go a little more depth in it. And the Sprite renderer is the component object that sits on the game object, where you can pull your sprites over and start rendering stuff into your game world. Scheduling. What do you mean how scheduling? Scheduling like events or scheduling something with the sprites? Oh, sure. So like these unit events up here. Like how what the unit events are and their sequence, like the ones that you have to be aware of anyway, on awake, on enable, start. You mean these? The fixed update and the update? Like how to call them in your scripts? Cool. Yeah, you let me just open up the player controller. You don't you can schedule. I guess you can think of it as scheduling your code. You can call these events as you need to from your C# classes. The first step is when you create a C# file in your Unity project. If you just kind of right click and create C# file, you'll get like a basic C# script. And the big things that come along is yeah, this one's inherited from kinematic object, so it's a little annoying. But let me just hear like this test script. Yeah, this is it. Perfect. So this is like a script that when you create it, this is the same, like the standard code you get offered up to. So usually the name of your class is the name of your file, and if it's not, you should change it because it didn't leave you together. But it is a class, and everything within here belongs to this class. And this is the inheritance operator, colon, and it's saying it's inheriting from mono behavior. And that's a big thing. So this mono behavior is coming from Unity Engine, using Unity Engine. It's a different library. Somebody wrote this C# file called mono behavior. And when you inherit from it, you get access to the events. And all you have to do is write methods out. So these are already written out for you, start and update. But you can write out the other ones, like if you needed access to, say, fixed update, you would just actually write it just out. And that actually did a little autocomplete for me. And this is the fixed update. This is what we deal with our physics code. Anyway, all you do is write out these methods in your class and make sure your class is inheriting from mono behavior and says using Unity Engine. And then you can have access to these Unity events. And so I'm going to jump back over to player controller because it's just a more built out script. And so here you see the awake. It is inheriting from kinematic object, but if I look at kinematic object, it is ultimately inheriting from mono behavior. So all this stuff comes along for the ride into player controller. But if I come down here, you can see that we have our awake function. So normally on enable or awake or start, they're known as initialization methods. And what you use them for is to initialize your scripts. So start is only called once, right, when your game runs. But on awake and enable actually can be called whenever the script component gets turned off or gets disabled. So these might get called more than once. But notice they're up here in this initialization. Like they're only called in very special situations. When your game first runs and that component object first starts up, or if with your code at runtime you like disable a component or turn it back on, they might run this awake or enable again. But these are only run like under, like usually once or just a few times under very special conditions. That's why they're known as initialization. And what you do is you like set up usually you go out, like here it's going out into the game object that player controller component is connected to, and saying, hey, go hunt around there, go get me all these other components because I need access to them. I'm going to call code on them. And update is used a lot, and it's usually used for user input. And so as we move away from initialization, here we have fixed update, which is fixed time steps. Usually it's like 0.02 seconds, and you do your physics processing in there. So fixed update method. And update is like usually the first one that you use, and it's the most common. And update is called as often as possible, and update deals with a frame. The idea of a frame is like a little fraction of a second. It's like your Unity game will run it as quickly as possible. It'll run through all the update methods as quickly as it can. But if you have a lot of game objects or very complicated update code in your update method, it might take a long time, and so you might not get as many frames per second. But if you have a really strong computer and you don't have like as much stuff happening in your update methods, then you'll get many frames per second. And so at each frame, it goes through like all the game objects, through all of their component objects, finds all these update methods, runs all the code in there, and it like updates the graphics. And it does all this as many times per second as it can. And so that's the idea of frames per second, frame rate. And usually it's like 30, 60 frames per second. And so there's all your game logic goes in there. Checking user input goes in there. Updating graphics is part of that situation. And then there's late update. So sometimes you want to make sure all your components have run their update methods, and then you want to run some code. So that's what late update is for. And fixed update. And fixed update is where you run your physics code. So it's interesting. It's like usually an update you check if there's user input. And if there's, in this situation, and with our player controller, we checked if there's physics input. And if there was, we changed some values so that when we went to fixed update, it actually did some work on our rigid body, on our physics components, and it moved our player. And I guess just some others to know about is that if you needed, when the player paused, you could do some stuff. On application quit is useful. It's the user's terminate your program. You might want to like wrap stuff up, save out like high scores, send save data to cloud or whatever. On disable is when you disable component objects. On destroy is when you destroy game objects. So these are called decommissioning events. And as far as player controller go, here's the update. Here we're checking for user input. And if we jump to kinematic object, which is like the parent class for this, so the code's inherited. If we come down here, we see that we have enable, disable, we have start, so we have some initialization stuff going on. But what's really important is we have our fixed update. And after we receive user input, which is messing around with like this velocity variable, whatever, it does a bunch of like physics processing, a bunch of math to figure out how we're going to move the character. Did you have any questions on Unity events? The schedule. So that's what you mean, you meant schedule. So these are events. These aren't Unity events. So when there's a collision, we were looking at like when a player and an enemy touch each other, and on the enemy side, the enemy side has on collision, like, we've touched some colliders. Let's check if it's the player. If it is the player, let's schedule this player-enemy collision, which can schedule other things. This is developer code. So this is code that this developer wrote. This is part of um, the game logic, and it's two. This is like an event system, and they are scheduling stuff, so it is actually kind of similar to the Unity event system, which I was kind of talking about one class. That the reason I don't like this is because it's like getting too deep into computer science, and this is the type of code and ideas that should be abstracted away by the Unity engine, and that's what the Unity events are for, like update and start, and they handle all this stuff. So I don't like the fact that this game developer included stuff like this, but just note that this game developer decided to put in their own little event system so that when you do fire off these events, we don't get all these like mismatchy mess of like running. Like say if like multiple events are like fired off in one frame, and we need to like, okay, let's process them out over a few frames. Let's not do all this at once. So he did that, but it's a little bit too complicated of a solution for a problem. It's called over engineering, and it's a common issue in the industry. But anyway, just know that basically you can see a little bit deeper into programming concepts that you normally would as a game developer, right? Looking at this, but you don't have to. You have to be aware and understand how to use Unity events, not like this developer's scheduling system that they devised. But so, for example, when there's a collision, just you don't have to understand how this scheduling is working, but note that okay, this player enemy collision class is being slipped in to our scheduling, so it must be being run somehow. So then you can go to the player enemy collision class and kind of read through it and say, okay, there's this execute method. So when this thing is scheduled to be processed as an event, we're going to run this execution code. And basically it's checking, hey, who's going to get hurt here? Is the player above the enemy? Should we be hurting the enemy? Or should we be hurting the player? And if we're hurting them, how do we hurt them? And how does the other person like bounce off them or something? So don't worry about going into the details of that schedule. Worry about going into the details of the Unity events that I just talked about. Does that make sense? Cool. So is there anything else to talk about with Sprite editors, Sprite renders, or any other topics? I think with my time left, since we just picked into the situation here with players and enemies hurting each other, I think I'm going to go back to how to process hurting enemies, and I'll move the tile maps off. I won't make tile maps part of this quiz. So I'm just going to stop briefly. Any questions about anything? There's going to be a quiz this Friday. It's on everything I've talked about. So the videos are up, and I'm recording one right now. And there's a study guide here, and the study guide just kind of covers the high level topics that those videos go through. Like, be prepared. Like, there could be questions on what's the difference between Unity Hub, Unity Editor, and Visual Studio. Like, you might say, hey, which of these packages do you write code in? And then the answer might be Visual Studio. And we went through the Unity Editor and all of its windows, and we talked about the package manager and importing in the platformer. And we talked about game objects and component objects and how the camera's kind of working and how to move around in 3D space. And then we talked about Unity events like start and on update, and C# basics like properties and fields and classes and objects. Just know them enough, like what I'm talking about. Like, the questions I made are directly out of, like, if I talked about something in my lecture video and I was like, oh, you know, that's a good thing to know about, I made a question about it. So here's the quiz. It's going to be 80 minutes. It'll start on Friday at 2:30. You can be home. You don't need to be on WebEx. Just click start after 2:30. You have 80 minutes, and it's 25% of your grade, and there's 25 multiple choice questions. All right. And the way that, since people are home and taking it, I just have some safety checks, like just give you one question at a time. You can't go back on a question, and you'll get like your total score at the end. So if there's ever like a question you're like, oh wait, I'm not sure about this one, or I think like the answer might be wrong, you just copy and paste it and put it in like a text file or something, and you can send it to me afterward. It's just I have to try to curtail some cheating. So you get to take it home by yourself, but you just get one question at a time, and you'll just get your total score at the end.
Okay, Professor. So do we need to log on to WebEx for it?
No. You just go to Canvas, click here, click start.
Okay, and when you say send you a file, like about like if I think I want to change my answer of a previous question, like I think I got it wrong, you said just
no,
send...
you can't change. You have to make your best guess. I'm saying if you're like, oh, I kind of want to talk about this later.
you mean like afterward?
I think maybe I did. Like I feel like this should be the. I feel like this might get marked wrong, but I feel like I'm going to be right. You can copy the question and just send it to me again. Talk about it.
All right then. Thank you.
And yes, when questions like 1% of your grade. I don't. Yeah. Do you need a camera? No. There's proctoring. You just take it on Canvas at home during class time. And if anybody got no, I already set up that stuff. So I already got letters, and any extra time is already set up. All that's set up. Just you get one question at a time. You just can't go back on it. And if you have any doubt, you're like, oh, this is a weird question, or I know I'm going to want to talk about this or something, just copy and paste it. It's my way of trying to just curtail cheating. And we just have four quizzes. Correct. Yeah. So if you start at 2:30, yeah, you'll have till 3:50. Correct. And if you start at 5 minutes later, if you start at 2:35, you'll have till 3:55. So the questions aren't meant to trip you up. It's just like, did you listen to me? Did you actually like do that? You're not supposed to just like listen to me during class time. You're supposed to open up, watch the videos and pause them, and then really try to break the game and try to like modify it. Try to really understand what is happening in the game engine. And so if I mess around with the player, try to speed him up, slow him down, try to make a different button make him jump or something, and then you'd be like, oh, okay, I'm understanding the concepts. So it's active learning. You actually have to do it. So there's extra time in class for you to experiment. And yeah, and but don't, like, you have a little bit of leeway. You could start the quiz a little bit late because technically the quiz closes at 5. But just start it. Just come to class. Just start it, and just take the quizzes. I'm not trying to mess you up. I just need a way to like grade your knowledge in the class material. And I'll take a look at the quiz grades, how the whole class is doing, if I need to do any curving. So don't worry about if you're taking the quizzes. So let's see, we got 45 minutes. What I did want to do is, and if anyone has any questions about anything, is curious about learning something, let me know. But right now, the player has 3 health. And let me just make sure he's working correctly. And I just got to go back to like, wait, how was I hurting the player? Like, let's see if you can hurt the enemy. Let's see, health is max 3, current 3. So he gets hurt 2, 1, 0. Cool. So one thing so he gets respawned, and that's one thing. So he gets respawned, and he has 1 health. So let's see. This game looks like you don't. So it's like more like if you have like 3 lives, it's more like you can get like really far into the game. I'm just gonna update this to like 3. But now I just got hit 2. It's more like, oh, I don't need to start all the way from the beginning, right? And if I do die way far out here, your penalty of losing all your lives is you have to spawn at the beginning. I mean, you could also say game over, restart, or whatever, but that's the way I currently have. One thing I see is that when you lose all your lives, you just have 1 life. And then the other thing there's a few other gotchas, little edge cases. So if I have 3, I gave myself 3 lives again. If I come at an enemy from the right side, it'll still spawn me on the left because I just hard coded the left side. That's one thing that I'm gonna try to quickly look at, and a bigger issue might be falling to death. I might not be. Yeah, falling. You just have 1 life, so maybe that's okay because you hit a different type of collider. You hit the death trap colliders down here. You don't hit an enemy collider. So there's like little tweaks. Let me see what happens when you die all the time and you get respawned and you only have 1 life. So I'm gonna have to go to the health script, which is sitting on the player. So what happens when you die? Decrement. So let's see. If the player enemy collision event gets scheduled, we decrement the health. Oh, that was something weird. Like health is 0. Yeah, I remember these. It's like the health script. Okay, decrement. Drop the health by a point. If we're at 0 health, we're going to schedule health is 0 event. And then this thing doesn't do anything. It just schedules a player death event. And the die method on health just keeps dropping the health down to 0. If for whatever reason you have a situation where you're dead, but you still have like some health left, we just kill all the health. But we stop the camera from following you. We disable player controllers. We play an audio, and we start changing the animation, the animator. Set trigger hurt, set bool dead. Yeah, I did go over the animator quite a bit too, so that's going to be on the test. And those are in my videos. But what we schedule is a player spawn after 2 seconds. So let's see what player spawn does. So we enable the collider on the player. We enable the user control. We play some audio. We increment health. And then we teleport them back to the beginning of the level. We set the jump state to grounded. We set the dead bool to false. We make the camera control them, and we enable player input within 2 seconds. Oh, I'm sorry. Player input was false. So within 2 seconds, you're able to use the player again. So it's somewhere in here. Let me look at health increment. So increment the health just gives 1 point. So I'm going to just create another method, just say public void, like reset health. And all that's going to do is just set current HP. Where do we start? Awake. just current HP equals max HP. I'm just going to run that code. Okay, and I'm going to call reset health on player spawn instead of increment. And let's just double check that that works. Just a quick note while I was building. So the test is online, and then like unfortunately, I sent that message in the announcement. Hopefully, everyone saw it. But yeah, like our baby got sick, and it was a little scary because I know babies can't breathe through the mouth, and her nose is all congested. And so I'm just gonna be. The doctor advised me to just stay online a little bit longer. Apparently, the first 2 months of a baby's life is like where they have like no immunity, and it can get very dangerous quickly. So just for the time being, I'm just going to be online and then figure out when I should come back. But that means next week we'll be online. So player health, 3, 2, 1, respawn, and we get 3 health again. That's great. So now the other issue I have is when you hurt the player and they're still alive, I just bounced them off in a direction, right? And I just picked to the left and up. And I just through play testing, I figured out what these values should be. But maybe I could use these bounds here. So here we're checking the Y. But I bet I could check the X's here. I bet I can take this, set a value to this. So if I'm going to go down here, let me say var direction. Let me actually call it what the real type should be so it's not as confusing. So if I hover over here, this is a float. So this should be it's a bool, right? Let me write this in easier code because they're writing a little bit compressed code that's a little advanced. So if I'm going to take this and pop it in here, if bounds center X, bounds center X. Okay, so if the player's X position is greater or equal to the enemy's X position, meaning they're to the right. So I could just write an if else here, get rid of this line of code, and just say like bool should bounce left, and I just set it to true. Like, okay, fine, we're always going to bounce to the left, right? To start with, but let's do a check here. If the player's X position is greater than the enemy, now then X, if it's greater, if you look at where I move it here, X is right now like half a unit, and if I move him to the right, notice how X grows more. So a bigger X, a more positive X means more to the right. So that means if the player's X is greater than the enemy's X, the little bounding rectangle around and take the center point, which is a vector 3, X, Y, Z. Let's grab the X part of it. And that means the player is to the right of the enemy, so this should be false. Else, we won't do anything. It's already set to true, so I'll leave that alone. So basically it's saying, hey, we're going to bounce to the left. But let's do a check here. If the player's X happens to be greater than the enemy's X, let's set this to false. All right. And I'll do a similar convention down here. Like here's our bounce to the left. But if we shouldn't, so an exclamation means not. So if we should not bounce to the left, then we will take dir equals new vector and go positive with it. So what this is saying is, okay, we're going to create a variable called direction dir of type vector2. Vector2 is an object that just helps us handle two floats, an x and a y. And we're going to set it equal to a new object of type vector2. And we're going to pass in some input and saying this new object of vector2, set its x to -2 and its y to 1. And these are floats, so you put an f after. Now, if we do a check, if we should not bounce to the left. So bounce should bounce left. If this is false, it's a bool, true or false. If this is a false, which means we want to go to the right, put a negate. So this exclamation point means basically flip it, whatever the opposite is. So if it's false, it becomes true. If it's true, it becomes false. So if, let's just say this was true. Let's just say we should bounce to the left. We're going to negate it, which means it'll turn false, which means we will never do this, which means we stick with this, which means go -x, go to the left. And if this is false, meaning we should not go left, we should go right, we'll negate it, and the false will become true. And then this will say, oh, this is true, I should evaluate this. And this takes this variable, which we defined up here, and says, let's set it to a new value. Let's set it to a new object of vector2 with positive x direction to the right. And whichever direction we end up going, let's bounce in that direction. All right, so let's try that. So we got the left side, boop, and we got the right side, boop. So it works well. And then I'm dead. Cool. So, is there any questions with what's happening here? Otherwise, I'll look at the enemy side. And I ended up going all the way to this last event and saying, hey, when we do respawn the enemy, reset its health, don't just add one to it. Cool, so we can look at the enemy now. So I believe the enemy doesn't have a health script on it. Yeah, no health script. So when we do figure out who are we hurting, the player or the enemy, if we're going to hurt the enemy, then go onto the enemy's game object and hunt for a component of type health. And if it's not null, which right now it's null, it doesn't have a health, we go down here and we say, hey, kill the enemy and bounce the player 2 units up. But let's put a health script on it, which means when this situation occurs, this will not be null. It will be, we will find a health component. And then we're going to go through like decrementing its health. And I have to check here. I don't think it should be scheduling its death anymore because I think that's happening in the health script. I have to be careful here because I think the health script now, when we decrement it all the way, health is 0. And that schedules a player death. Okay. So basically I want to know, is this script sitting? I don't want this to be called if this script is sitting on the enemy. So what you can do is go up and on awake here. Yeah, so there is an awake. What I'll do is I'll say private player controller. I'm going to set it to null, which is what the default is. If you don't say anything, it'll just be set to null. I just want to show you that you can explicitly set this. This is null to start with. Now, on awake, we can say you are equal to, look like it, yeah, get component player controller. So what it's going to do is it's going to on awake, when this script component awakes, let's see what the issue is. Yeah, nothing. So on awake, this health script says when you wake up, when you first turn on and you're awake, go whatever game object you're on, look at all these components and see if there's a component of type player controller. That's all you're doing. And so for the player here, you can say, hey, if the current hit points equals 0 and player controller does not equal null, then we're going to schedule this, which is really like that player death event. Because I'm about to assign this health script to enemies, and so I don't want this to be run whenever the enemy dies, or else it's going to kill the player too. So this is basically saying, hey, am I on the player or not? So when this health script is on the enemy, yes, we'll decrement, but this will always be false. We'll never schedule this event for the enemy, which means we have to handle it ourselves. So it's okay to do it over here, schedule enemy death, right? Give me 1 minute, class. Hold on 1 second. I got
Where is it?
What? Oh, it's in the sterilizer.
It's in the sterilizer?
Yeah. Sorry. Baby needs the nose suctioned out. Cool. So I think I have this set up. And I'm going to click on this enemy. And I got to go find the health script. Health. All right. So let's say an enemy has, let's just start off with 1 health. Let's just see if this works. So what should happen is I'm going to jump on this player. He has 1 health. And what should happen is that we're here, right? We're going to get a player-enemy collision. We're going to figure out we should hurt the enemy. We'll figure out that the enemy does have a health component. And we're going to decrement. And we are at 1. And it'll go to 0. And this will be false. The enemy won't be alive anymore. Because is alive is here. Remember, and it's got this like anonymous function. You don't really need to know it. But it's like saying, okay, whenever you check this, it'll like run this line of code. It'll say like, is current HP greater than 0? So this is a logical expression. So if this is 1 greater than 0, this is true. And if it's 0 greater than 0, this will be false. So this will be false after this decrement because he only has 1 health. And we'll run this check, which will return a bool, and it'll return false. And then we'll schedule the enemy death, and we'll have a small bounce up. So let's give that a try. Get this null ref. This doesn't have anything to do with me. It's something with one of the editor scripts is acting up, maybe because I'm messing around with stuff. But I want to go, okay, cool. I have this enemy. It's got 1 health. and you kill it, and health was 0, and it's dead. Cool. Let me just double check. I take damage, and there's nothing weird and funky going on. So when I kill the enemy just calls that enemy death. It doesn't like do anything with the player. It doesn't kill the player. Yep. Cool. So let me think about a situation where, let me just not show these errors anymore. Let's give the enemy 2 health. So what should happen is there'll be health component on the enemy. You're going to decrement it, go from 2 to 1. It will still be alive, so this will be true, which gets negated to false. So we won't do this, and we'll go over to here, which means give the big player a bounce. I'll go up in the air, and I'll come back down, and I'll initiate another collision event, and we'll decrement the enemy health again, in which case the enemy is not alive. This will be false, negate it to true, and we'll schedule the enemy death. All right, here's the health. So I hit him down to 1. I can hurt myself, and I'll jump on him, and I'll kill the enemy. Cool. So enemies can now function with and without the health script. So what I had to do here was, most of this code was existing, if you remember, that it looks like the developer was getting ready to implement something like this. So I didn't touch this, but in the health script, I did have to make this field of type player controller, and I called it player controller, and I set it to null. And then on awake, when this component object awakens for the first time, set your current HP, and then go out, whatever game object you're on, call get component out, go out there and look if there's a component of type player controller on this game object. And if so, assign it to our variable, our field of player controller. So this starts off null, and maybe it gets set to something if it's on the player, but if it's on the enemy, it stays null. So whenever the situation comes that we keep decrementing health on whatever this is, and that health gets to 0, we know, hey, if your health is 0 and you are the player, then we're going to schedule this event. I'll let you handle player death that way. Otherwise, if we do get to 0, don't worry about it, because we're on the enemy, and I'll schedule the enemy death over here. Any enemy death event looks like, take the collider, set it to false, put the control of the enemy, whatever AI control is happening, turn it to false. And if there's audio and there is an ouch audio, play the ouch audio. I should say there's an audio component. And there's an audio clip called ouch. Then go to that audio player component, call play one shot, play the ouch. Cool. Any questions? That kind of wraps up that. Let's do want to explore modifying health for player and enemy. So, what do you think so far? Did some good explorations of 2D platformer. You feel comfortable, you understand what will be expected of you on the quiz, and I'm going to get one more video up, which just happened today, and I'll go update the study guide for what happened today, which was just more of like a recap on Sprite editor and Sprite render, and then I kind of dived a little bit more deeper into checking some edge cases with player health. It's more like health, like player health edge checks and enemy health modification. fill that out and get this video up. And next try will be a quiz, and then the Tuesday after will be online as well. I'm going to be online for a bit.
Okay, and I just want to make sure you said we don't need to be on. We don't need to go to the WebEx for the quiz, right?
Mm-hmm. Yeah, you can just take the quiz when the time comes.
Okay, I just wanted to make sure because I wasn't sure how my PC was reacting, why I couldn't connect to audio on my PC for some reason. So